So let's take a look at Pytorch deep learning framework. So basically this is a framework that is used for working with tensors and other numeric computation within deep learning. Now the thing about tensor is that it is basically an n-dimensional numpy array that is often used for calculations related to neural network or numerical computation that makes use of GPU. Now in case of Google Colab, you have option here within runtime menu to change runtime type. So here when you are making use of your Pytorch library, you can use GPU, right? And you can then save it. Right now let's add a code block, and here we are going to import few libraries like import torch, right? Then import numpy, right? Then we also have to call for matplotlib dot pyplot adds plt, right? So these three things we are going to use for working with our tensor and plotting graphs with our calculations, so that we can see how we can do operation related to n-dimensional numpy arrays within our tensor calculations. So first thing to do would be working with tensor, where we can create various type of tensors and then learn how to initialize them, then do mathematical operations with it. So now let's take a look at how you can create tensor. So basically tensors are your n-dimensional array that you can create by using your typical numpy library, but here in case you will have to do it differently. So let's say if I create array of x that contains ones, right? So we create 3 by 2 matrix for that, and we simply print it out, right? So here you see I'm calling for torch, then calling this once method which is from numpy, right? So if I run this, it should show me the output containing 3 by 2 matrix, right? As you can see, you got the tensor that shows the 3 by 2 matrix, the one you wanted. Now similarly we can also call, let's say, another tensor that has let's say even zeros if you want, right? So zeros 3 by 2, right? And we print this one out, right? And if I run this, it should have another tensor. So we have two tensors with ones being ones of 3 by 2 matrix and zeros of 3 by 2 matrix again, right? So this was one of the example for creating your tensor the easy way. Now there is also a method where you can create a tensor with random initialization. So we will be having much random data. So if I remove this, and here let's say if we create, let's say torch dot manual underscore seed, then we will have seed of 2, and if we choose to create an array, so x equals to torch dot let's say random for 3 by 2, right? And then simply print x, right? So if we run this, we get the random value there, right? Another thing is we can also change is, let's say for y we make use of torch dot ran in method for 3 by 3, and then print this one out, and you get 3 by 3 with ran in method, right? So here you can see how to create multiple ways through which our tensor can be created, right? So basically we create by calling the ones method, zeros method, or using rand method or rand method for random data. Now let's take a look at how we can create a slice of tensor. So for that, let's go for our array x, then torch.tensor, right? And within that we will have this 1 by 2, then on new row 3 4, finally 5 6. Now if we want to slice this, how would we proceed? So we will try to have every row sliced, so we can do that by using this colon and then simply 1. So every row 1 column, right? So that's one. There is also option for, let's say, x, where we have every column being sliced. Just like we did a row, we can have it for column, right? That's one more thing, is we will try to have element in first row and column. For that we will do x11, right? And then print y, right? So let's take a look at if this works. Okay, so to solve this error, how you can do is add one more bracket so that it gets resolved, right? And then we can run this, and here you see our first tensor being sliced 2 4 6. Then second way where we have our column being sliced, right? And finally with y we managed to get tensor of 4, right? So we have managed to slice our tensor, right? So let's take a look at reshaping of tensors. So let's say if I create an array of x, then torch dot tensor, and then within that we will create our first set of data, right? So let's say if I create 2 3, then let's say 4 5, right? Now that we have our array, next thing we can do is we will try to get the view within 2 by 3, right? And store that in another array. So we will call for this view method by using our previous array, and then go for 2 by 3, right? Now the thing is, here we are shipping from 3 by 2. Notice that it's 3 by 2, right? 3 rows and 2 columns. We are going to do 2 rows 3 columns, right? So let's see if we can do that. So print y, right? And as you can see, 2 rows 3 columns, right? Now this is one of the way to reshape it. Another method is to use -1. So while using -1, it indicates that shape will be from your previous dimension. So let's see how to do that. So let's go with our previous tensor, and we will try to use -1, right? So for that, let's say if I go for 6 and -1, so let's see how it changes the result. And as you can see, what it has done is it has tried to create 6 rows, right? And kept within that is only 1 column, right? And then we have our regular output of x, because we printed x here. So let's run again, and as you can see, it has managed to create 6 rows and only within 1 column. So these 2 ways you can see and experiment with for reshaping your tensor. Now let's take a look at some of the mathematical operations that you can perform on your tensor. So first thing, let's create an array with our tensor with value of ones, and for that we will have 3 by 2 of matrix. Then let's say torch of ones again with the value 3 by 2, right? And next thing is, let's say if I want to add these two, then I can simply go x plus y and then print z, right? And if I run this, we can see our two values from x and y now added. Now there is one more method. Instead of x plus y, we can also use the method called torch.add and then pass x, y to that, right? Which should result in same output, right? Now what if I want to use, let's say, subtraction? So for that, what we will do is, let's say x minus y, considering both are having same values, it should be easy to see 0 as output. Similarly, we can also use torch dot sub and then x y, right? And if I run this, it should show the same output. So you get the idea how to do addition, subtraction, like mathematical operation with your tensor. Okay, so let's take a look at some of the tensor conversion options that we have. So first thing, we'll try to convert numpy array into tensor array. For that, let's say x is my numpy array, so np.array, and inside that what we will do is we will basically type in some values: 10.1, 11.2, 12.4 and 13.6, right? So 1, 2, 3 and 4. Right now the next thing we are going to do is we are going to convert this into tensor, right? So for that we will call torch dot from underscore numpy, right? So this function takes your value of x, right? And then we will simply print few parameters, like let's say if I want d type of this particular y, so what I will do is, let's say y dot d type, right? And also we will also get, now this d type that you see is basically the data type, right? Then you can get tensor type, sorry, should be inside, right? So y dot type method, right? So if you print this, now as you can see it says no attribute from numpy, so I missed y here, right? So let me run this again, and as you can see we got things fixed. So torch dot float 64 is our data type, and also the tensor type is double tensor, right? So we managed to convert numpy array into tensor array. Similarly, we can also change the data type. So let's say if you have an integer, so within x I have this torch dot float tensor, right? So we use this before we convert our integer list. So let's say 10, 12, 14, 16 is the integer list that will be converted, and then what we'll do is we will simply call for x dot type, right? And also the, sorry, x should be method, right? So if we do this, integer to float conversion should be visible, and as you see it's float tensor now, right? Similarly, you can also try out for your other values like float, double, or within the reduced conversion like float 32 converted back into float 16. You can go through that as an exercise, right? Then one more thing that we can convert is pandas series. So let's say import pandas as pd, right? Now that we have pandas series pd dot series, and within that let's say 2.2, then 4, then 6.2, right? Now what we can do is we can simply create another array to hold this, right? Or basically x is going to hold the values from our pandas series, so we will call torch.numpy. So what it will do is it will try to convert this series into tensor, right? So ps dot values, right? Then what we will do is we will print out few things, like first we will print out this x that holds the conversion of pandas series into tensor value, right? Then it should also print out x dot our d type, right? And also the x dot type, right? So let's run this. Okay, so the missing thing here is torch dot and then from numpy, because we are doing the conversion, so we'll be using from numpy. Sorry about that. So 2 errors fixed, and here you see your tensor is ready. So from pandas series we managed to get a tensor. Also its type is integer and data type is integer 64, and tensor type is long tensor. Now there is one more thing you can do, is basically shuffling the tensor elements. So let's say if I import TensorFlow as tf, right? And then what I will do is I will create my tf.constant that basically contains 1 2, right? Then 2 4, then 4 6, then 6 8, right? So we have those things ready, right? And after that what we will do is we will go for tf.random, then set underscore seed, and let's go with 123. And now what we will do is we will have, now next thing that you may notice that we have to create another tensor that will be holding tf.random.shuffle and then value of our x, and then finally print out this particular y, right? If you run this, we get shuffled order for this particular tensor. So let's take a look at how to find the index of min and max, and for that we have already imported TensorFlow as tf. Now next thing, we'll create our tf.constant within which we will be holding list of values, and within that let's see if I have 2.4, then 6.8, then we have 10 and 12, right? So some of the values we have, and within which we want to find out index of minimum and maximum of that. So index minimum equals to, let's see, tf dot argmin, and then we pass x to that, right? And then for printing out the values, what we will do is we will simply use tf.print instead. So for a change, let's go with this, and here let's say index min, right, and then comma, and then we will pass index underscore min, right, then also tf.print, and then pass in min, and then we will be going for x of index min, right. These two values we need to print out to see our index of min and min. Right, so index of min 0 and min 2.4, right. So going after this, so what we will do is we will also have to find max, right. So tf dot constant we will keep as is and change index max, right. So for that we will call for the value of tf dot argmax and then x, right. So after that what we'll do is we'll use tf.print, then same index max, and then we will simply show our index max, right. Similarly tf.print, and then we will have max of that, and then our x of index underscore max, right. So we have index max and max values from this output. As you can see, index max is 3 and max is 12, right. So you get the idea, the way to find out index of min and max within your list with the help of your TensorFlow tf constant and tf argmin argmax methods.